Welcome to my channel. My mission is to help the engineering students to master the complex mathematics through clear step-by-step solutions. If you are preparing for engineering mathematics courses for universities like JNTUH, JNTUK, JNTUA, and also for another competitive exams IIT-JEE, you are in the right place. I specialize in breaking down the difficult example problems into clear step-by-step solutions, so you can walk into your exams with total confidence. And this is the change of order of integration problem series, problem number 4. And the previous 3 problems links are given in the descriptions, so you can watch and share these videos to your friends. Now coming to our problem, and this is the problem number 4. By changing the order of integration and evaluate integral 0 to a integral root of a square minus x square square root of a square minus x square minus y square dy dx. Now see the outer integral limits. The outer integral limits are, inner integral limits corresponds to y and the outer integral limits corresponds to x. So the outer integral limits are from x varies from 0 to a. The inner integral y varies from 0 to root of a square minus x square. Now observe the boundary analysis. Since y equal to root of a square minus x square on the boundary, therefore x square plus y square equal to a square. This is a circle of radius a centered at the origin, and this represents our region R represents the first quadrant of the circles, because the lower boundary y equal to 0, means in positive x axis. Next the left boundary x equal to 0 represents y axis, and x square plus y square equal to a square combinedly gives the quarter circle like this. Since the original order, we first integrate with respect to y first, this vertical strip, and then x. So if you change the order of integration dx dy, we first integrate with respect to x, next with respect to y. So first we are integrating with respect to x, that means we take the horizontal strip like this. So how to find the limits? So we first we draw the horizontal strip through the region and identify where this strip enters the region and where this strip leaves the region. So it enters at x equal to 0 here and leaves at, since this is x square plus y square equal to x square, a square, since x limits must be functions of y, so we will write x square equal to a square minus y square, that means x equal to positive root of a square minus y square, because this is in first quadrant. So x varies from 0 to root of a square minus y square, and y limits, and if you see in the lower one y equal, so here 0, and the upper one a, so y varies from 0 to a. Now our new integral becomes this equal to I equal to integral 0 to root of a square minus y square, and this integral corresponding to x, and outer integral 0 to a. The integrand root of a square minus x square minus y square dx dy. Hence for evaluating this integral, now I am converting this into given integral into polar coordinates, because the region is circular. This is quadrant circle, so we are using polar coordinates. So the polar coordinates x equal to r cos theta, y equal to r sin theta, and dx dy equal to r dr d theta. Now so for after substituting x equal to r cos theta, means these polar coordinates, right. So this is root of a square minus if you take minus common, a square minus of x square plus y square, since x square plus y square equal to r square. So this becomes root of a square minus r square, and dx dy is r dr d theta. Now we want r limits and theta limits, and remember that in polar coordinates r limits are functions of theta and theta limits are constants. Now how to find the r limits? And draw the radius vector through the origin and identify where this radius vector enters the region and where this leaves the region. It originating from the origin, that means r equal to 0, and it leaves at this one, r equal to a. Since x square plus y square equal to a square, that means r square equal to a square, that means r equal to a. So r varies from 0 to a. Since this is in positive first quadrant, therefore theta varies from 0 to pi by 2. So now our new integral becomes integral 0 to pi by 2, integral 0 to a, square root of a square minus r square, r dr d theta. So this is integral 0 to pi by 2 d theta, integral 0 to a, r root of a square minus r square dr. Since these are constants, right? 0 to pi by 2, 0 to a. So the order of integration is immaterial. That means first we integrate with respect to theta, next with respect to r, or first with respect to r, next with respect to theta. Since integral d theta is theta, and after substituting the upper limit, this becomes pi by 2. So pi by 2 integral 0 to a, r root of a square minus r square dr. So for evaluating the integral, so we take the substitution u equal to a square minus r square, so that du equal to minus 2r dr. That means r dr equal to minus 1 by 2 du. So if you change the limits, our r limits becomes r equal to 0, u equal to a square. When r equal to a, u equal to 0. So our new limits are from 0 to a. U limits are from 0 to a. 0 to a, 0 to a square, and root of, since a square minus r square equal to u, so that means root of u, and dr equal to r dr equal to minus 1 by 2 du. So root u means u power 1 by 2 du, and this equal to 1 by 2, integral u power 1 by 2 is u power 3 by 2 by 3 by 2, just like integral x power n dx equal to x power n plus 1 by n plus 1. So u varies from 0 to a square, and this equal to 1 by 2 into, now 1 by 3 by 2, this is 2 by 3. Now after substituting the upper limit, this is a square whole power 3 by 2, and that becomes a square, a power 2 into 3 by 2, 2 cancel, that means a cube by 3. So your I equal to pi by 2 into, and this integral limit a cube by 3. So this is pi a cube by 6. So the final answer is pi a cube by 6. Thank you.